exercise 4. All right, so what is it that we're ultimately looking for with exercise 4? Well, essentially we want to make sure that we're able to heat the overall interior of our entire building as much as we can through passive solar heating. So what we want you to do is use your current design of your residence and look at trying to create thermal zones. Well, thermal zones can be whatever it is that you want them to be. They could be individual rooms for all I care. Realistically, for things to work very well, ideally you want to try and group rooms together. So maybe you have it to where there's one large open area where it's your living, kitchen, dining, whatever it is. You can make that one zone, and then you can make everything else a separate zone. At the very least, you need to have at a minimum of 2 zones. At a minimum, 2 zones. And what we want you to do is pay attention to when that room or that zone is actually going to be used. So think carefully of when it's primarily being used and try to design your thermal systems based on when they're being used. So think about it logically. Your bedrooms are probably going to be used more at night when people are, well, sleeping. So maybe you want something that's going to last longer through the night to keep the space comfortable. Your living, kitchen, and dining area might be used mainly during the day, and maybe you have it to where there's a specific spot that people are going to congregate towards as soon as the sun rises. That's up for you guys to decide and for you guys to explain. Okay? Questions on that? All right, from there, we want you to highlight all of the thermal mass that you have that is open to your solar collectors. So wherever you design your thermal mass, make sure there are windows that allow for solar radiation to hit them. And we want you to show us that. Where are you designing your thermal mass? Whatever system you want to design, just show it to us. And show us where your south-facing glass is going to be located. Show us how you're going to control it. Just give us some simple diagrams. Are there any controls? Do you have it to where there is night insulation? Show us that. Do you have it to where it's going to be protected during the summer? Show us that. So that way no solar radiation actually hits it. Yes? It could be just diagrams, absolutely. We just want to understand how it is that you're actually controlling it, okay? We want you to explore at least 2 options per thermal zone. It can be the same 2 options for each zone, but try 2 options per thermal zone. So, try a traum wall and just a direct gain system. Try a direct gain system and roof pond. Just try 2 different things. Okay? Then we want you to select one of those. So go through, do the calculations, see what happens, see if you like one over the other before you actually implement it in your design. But choose one of those 2 systems and explain why you chose it. Is there a particular reason why you chose it? Is it because, well, the square footage is less? That's a great reason. Is it because, the overall cost might be less? That's a great reason. Is it because of, it's able to work effectively more during the morning versus the night? That's a great reason. Explain why you chose one over the other. So effectively compare the pros and cons for each of those systems. And then design the one you chose and put it in your building. That's where you effectively highlight all of your thermal mass. Design something, put it in. Does that make sense? And obviously make sure you have everything that's required as far as any graphs, everything, you know how it goes. Pretend I don't know a fucking thing that I'm talking about and that you guys need to explain it via everything on paper. Does that make sense? All right. So how do we actually come up with our thermal massing systems? Well, the first thing we need to know is, what do we want our solar savings fraction to be? How much energy do we want to save? And ultimately, is it actually effective for us to actually go with a higher percentage of windows to actually get us more savings? Again, the example that I always go to is Madison, Wisconsin. We can effectively double our overall square footage of windows and only increase our solar savings fraction by 2%. Is that really worth it? Yeah, no. It's not even close. So let's look at Las Vegas. So we've got Las Vegas, Nevada, right here. We've got our overall percentage of windows, high and low. So let's draw those two lines. So we've got 9% and 18%. So we come down to this graph and we're just going to draw a line straight up from 9% and from 18%. Now, if we decided to go with no night insolation, we're effectively going to have a solar savings fraction between 35 and 56%. So we have 35% if we go with the lowest percentage of glazing, so only 9%, all the way up to 56% if we go with our high glazing with. So effectively, this is our line from Las Vegas with no night insulation. And you can see that if we double our overall glazing, we have a significant increase in savings. Is that enough to justify going with more glazing? I'll leave that up to you guys. Now, what happens if we go with night insulation? Let's see if there's any significant savings there. We're between 48 and 75%. So we go 48 for our lowest and 75% for our highest. And you can see that we can have even greater savings if we go with that night insulation. Again, I'm going to allow you guys to decide what strategies to use. Now, if you wanted to, you could figure out, if I'm looking at my south facade, I can look at what I've already designed for all of my daylighting and anything that I adjusted for my overall building envelope and just see how much glazing I have all facing south already and compare that to what my overall square footage is for my entire building. So let's say that I've already designed, let's say 10% glazing on my south facade compared to my overall square footage. Well, if I wanted to keep that, not adjust anything at all, I can figure out exactly how much of a solar savings fraction I would have for Las Vegas by just figuring out where those intersects are. So I don't even have to change anything if I don't want to. As long as I land somewhere within this percentage, 9% to 18%, I can figure out exactly what my solar savings fraction would be, ultimately. So may as well use what I've already designed, right? I don't have to change anything. It already works for everything else. Why change it? Now what happens if I'm way over 18%? If I added up all of my south glass? Well, that's where you can kind of select which glass do you actually want to use for passive heating, and which ones do you not just care about. You can actually decide that if you wanted to. That's okay. You can actually have it to where some windows just aren't used for passive heating. Or if I'm less than 9%, what does that mean? Well, it means that maybe you should add a little bit of glass just to make sure that you actually effectively heat the interior of your building. Does that make sense? All right, so let's say I got my 10%. Let's say I'm doing night insulation. Let's go ahead and move over and see exactly what my solar savings fraction is. I'm about 52%, which that's a huge number. I can effectively save 52% worth of the energy that would be required to heat my building just by designing a passive system. That's a lot of energy. Now, what if my building is not facing directly south? I need to make an adjustment. If you're not facing directly south, you have to adjust because of the overall efficiency of your system compared to a true south-facing system. So let's go ahead and assume that I'm not facing south just to show you what actually happens. Let's say I'm facing 20 degrees east of south, or west of south, sorry. West, east. It really doesn't matter because they both are exactly the same, so who the hell cares? And let's say that I'm going to design a direct gain system, the simplest system to use. So I'm designing a direct gain system, which is the second to bottom line. Where these intersect, if I move all the way over to the left, that tells me what the effectiveness is. I'm at about 95% effective. So that means realistically, if I were to design everything with only a 52% solar savings fraction, I may only achieve about a 50% solar savings fraction. So for the purposes of trying to ensure that I get 52%, I actually need to oversize my system a little bit because I'm not facing directly south. So for the rest of the exercise, I'm going to assume that I have a higher solar savings fraction, so that way it helps increase my overall windows, it helps increase my overall thermal mass. So I'm going to take my 52% and divide by my overall effectiveness. So 95%. And what does that give me? Any guess? Anybody do it? 0.52 divided by 0.95. So 0.55 or 55%. So that will allow me to slightly oversize my south-facing glass, and it will allow me to slightly oversize my overall thermal mass. So in order to figure out exactly how much glass I should actually have to achieve 52%, I would come back here at 55%, go to where my intersection is, and come straight down. And say, okay, instead of 10%, maybe I need 11% in order to effectively get 52%. Otherwise, if I stay at 10%, my solar savings fraction will not actually be 52%. If you do not wish to adjust your overall square footages at all, you can take your 52% and multiply it by your effectiveness to find out what your new solar savings fraction actually is. So this is if you wish to adjust. And multiplying them together is if you wish to not adjust. This will give you your new solar savings fraction. So 52% times 95%. What does that give you? 49%? So this is if you do not wish to adjust. Does that make sense? Questions? All right. Now I need to figure out, okay, if I'm doing night insulation, I need to know how effective my night insulation is compared to a full R9 only open 8 hours. So if you do an R9 open 8 hours, you're pretty much good. But let's say you want to do something a little bit different. Let's say I only want to use a full double glazing, which means I'm going to start with an R2. I'm not doing low E. Maybe I'm cheap. I don't know. And let's say instead of an R9, I go with an R4 because again, I'm ridiculously cheap. And it's only open 8 hours of the day. That means effectively, my R value is an R5. And with this number, I can move over to my night insulation at an R5. So we got R5. I go with my direct gain system here. And where these intersect, again, will tell me my overall effectiveness. So I'm at probably, what, about 88%? Again, if you wish to adjust your overall square footages for your thermal mass, as well as your windows, you will take your overall effectiveness that you created with your adjustment to face south and divide by your overall effectiveness for your night insulation. If you do not wish to adjust, you will take your overall effectiveness compared to south and multiply it by your effectiveness for your night insulation. Does that make sense? So if I wish to adjust, I take my 55%, I divide by 88%. So this is if I wish to adjust. If I do not adjust, you take your 49% and multiply it by 88%. So what do we get if I wish to adjust? All right, 63%. And if I don't wish to adjust, 43%. So if I don't adjust my overall square footage for thermal mass and my glazing, then effectively my solar savings fraction, instead of being 52%, I'm now down to 43%. That's a big chunk that's now no longer going to be used. But if I do adjust my overall square footage for my glass, utilizing 63%, so if I came back here and used 63%, went over to my night insulation and came down, that'll tell me what my new glazing ratio should be. So realistically, if I wanted to ultimately achieve 52% solar savings fraction, at the very end, I need to be somewhere around 0.135, so about 13.5% for my glazing. And I would use the 63% to figure out my overall thermal mass. Otherwise, I'm going to stay with 52% throughout the entire exercise and know that at the very end, I'm actually only going to have 43%. Does that make sense? Okay. So again, if I wanted to figure out what my thermal mass is after adjustment, I'm going to go to 63% and create a line. Otherwise, I'm going to stick with 52% and create a line. So this is with my adjustment. This is without. And this is if I want to do a full direct gain system. Pay attention whether you're doing direct, indirect, or you're doing some form of phase change. So pay attention to that. Again, imagine that budget doesn't matter unless you want it to matter. Okay? I'm not going to be critical about budget. So if you want to use a phase change material and spend a lot of money, I don't care. Just try something. Okay? So let's say I want to use 4-inch concrete. I'm going to find where it says 4 to 6-inch concrete here. And remember, I have a range here, an overall range for my concrete. If I go with the thinnest concrete, I need more square footage of that overall thermal mass, so I'm going to go with the high line. If I go with the thicker material, I need less square footage, so I'll go with the lower line. I'm going 4-inch, which is the smallest out of this range, so I'm going to select that highest line. And you'll see that if I were to have adjusted to ultimately get to a 52% solar savings fraction, I'm somewhere around 3.9 square feet for every 1 square foot of south-facing glass for 4-inch concrete. If I didn't adjust and left myself to be at a 43% solar savings fraction, I actually only need about 3.2 square feet of concrete for every 1 square foot of glass. So you're going to take this and multiply it by your glazing area. Does that make sense? So let's take an assumption and say my overall thermal zone was 1,500 square feet. I'm going to be lazy and I'm only designing one for my actual house. I know I'm supposed to do 2, but I'm lazy, and that's just the way I roll. So 1,500 square feet, I multiply it by my overall percentage of glass that I have. Either 0.1 if I only went with a 43% solar savings fraction, or 0.135 if I wanted 52%. So I either multiply by 0.1 or by 0.135. Let's see what happens for both, just to see what ultimately comes about. In this case, I've got 150 square feet of glass. And if I took the other one, 1,500 times 0.135, I end up with 202.5 square feet of glass. So an extra 50 square feet of glass if I wanted that 52% solar savings fraction. Again, it's up to you guys to decide or argue either way. Then we would take this and multiply it by our overall ratios here. So if I didn't wish to adjust, I multiply this top one by 3.2. If I did adjust, I multiply by 3.9. So without adjusting, I only need 480 square feet of concrete. So at 43% solar savings fraction, that's all I need. But if I want to go with the extra additional solar savings fraction, I'm going to need an additional 309 square feet of glass, almost 310 square feet, almost effectively doubling it. All to achieve an additional 9% solar savings fraction. Is that worth it? I don't know. That's up for you guys to decide. And again, it's the exact same steps, whether you go with an indirect system, whether you go with a phase change material, it's exactly the same. If you want to use a roof pond, there are additional tables that you can actually use for a roof pond. If you wanted to use earth-air heat exchange, you can use that. This right here is just the base system that we actually have supplied. Yes?
Where did that 0.135 factor come from?
If we wanted to ultimately achieve the higher solar savings fraction, we actually needed to come back here and adjust. If we adjusted overall with the overall tilt that my building is at, plus the overall ineffectiveness of my night insulation, my solar savings fraction is now all the way up to a 0.63, just to achieve, ultimately at the very end, 0.52, right? So I come back here to my overall window ratio, come up to a 0.63, where I have my night insulation, come back down, and that tells me what my window should be. Does that make sense?
Yeah.
Okay. Yes?
So this whole process was just for one zone, right?
That would be for one zone, for one strategy.
Okay.
But again, we just went through this in 15 minutes. Once you do it once, it's going to be a lot easier to do it again. And it's going to be a lot easier to do it again. And again, ultimately, I don't care if you guys fail. I don't care if this doesn't actually work at all. I just want you to attempt something. Try it, see what happens. Be bold, be creative. Do something that's different, something that you've never done before. Because I'm certain that none of you guys have actually done this before, right? So try it. Are there any questions? Nothing? Yes?
So after we test the strategies, do we need to update those into our design?
Yes. So for each thermal zone, you'll try two different things. Go through the calculations for two different systems. And then look at those systems and see, okay, what were the pros and cons for each of these systems? and which one do I ultimately want to choose? Which of those two strategies do I think works effectively? And once you select that, put it into your design and show me where it is. See what works. Yes?
So kind of those animations that you were showing us in the lecture earlier, drawing those where the sun.
If that's what you think is necessary, go ahead. It's whatever drawings that you think effectively show us that you understand the system and that you've designed it in the actual building. Any other questions? All right, that's what I have for you. For those of you that actually turned in a redo of exercise